Okay, the figure shows the graphs of the function f, the derivative function f prime, and the second derivative f double prime, and we want to identify each curve. First thing we want to do is let's locate any of the tangents on these graphs. Well, let's first take a look at this graph A. Okay, so if we take a look at the graph A, okay, let's check and see. So we have a tangent line located right there. Okay, and with that tangent line, let's just check and see if there is an x-intercept on that derivative function. Okay, so if we find this curve right here, so at this tangent line we can see that there is a point that is an x-intercept there. Okay, so that doesn't necessarily mean that this is the function, but let's now take a look at the slopes. Okay, so if we take a look at the slopes now, okay, you can see here that the slopes are increasing, which means the graph of B is starting above the x-axis, and then it gets to a tangent there and it starts decreasing. So that means once this goes up, then it's going to start decreasing. So we can say that A is going to represent the function f, okay, which then would mean that either B is the second derivative or C is the second derivative. Well, you can see here that we have a horizontal tangent at B, excuse me. So there is a horizontal tangent at B, okay, and let's just label that graph green since it is already green for the function B. Okay, so there's the horizontal tangent. So let's take a look and see if there's an x-intercept located according to that. So here is an x-intercept on that graph, and there is that x-intercept from that tangent line. Therefore, we would then say that B does have an x-intercept there, which is applying to C. So now, if you take a look at the graph of C, let's take a look at those tangents. So they have a horizontal tangent there, and they have a horizontal tangent there, but it does not have an x-intercept there, and it does not have an x-intercept there. So what we're going to say now is that the graph of B is the first derivative, and then we would say that C would represent the second derivative. So we can say it as follows. Okay, we have the following. We would say that A represents the function f, B represents f prime, which is the first derivative, and C represents f double prime, which is second derivative. And again, we can see this because where A has a horizontal tangent, B is equal to 0, and where B has a horizontal tangent, C is equal to 0. And we can immediately see that C can be neither of f or f prime, since at the points where C has the horizontal tangents, neither A nor B is equal to 0.